In this video, we'll see how we can deploy the model that we trained in the last video. So we have this MNIST classification model repo where we have 4 different models, and we sort them based on the validation accuracy, and we decide that this is the model that we want to deploy. So if you go to the models tab, from here you can get the identifier for this model. We call it the FQN. Now let's see how we can deploy this as a gradio application. So I have this VS Code here where I've written a small gradio application that can make the prediction based on this model. So you basically have a predict function that takes an image in the PIL format. It converts that to an NumPy array and makes the prediction using the model that we load. And the way we load the model is using the MLFoundry library. So we do mlf.getClient followed by getModel function. And to the model function, we pass the model version FQN that we can copy from here, right? And in this case, we are not directly passing the model FQN, and we are actually setting it as the environment variable. This is useful because if you want to update the application, then you don't have to update the code. You can just update the model version FQN, and the new version of the model will become live on this application. And finally, I have the gradio interface, which I'm serving on port 8080. So app.py is there. The second file that I have is requirements.txt, where I have all the Python libraries that I want to deploy, that I want to install in the deployment. Now to actually deploy this file, we need a third file, which is the Service Foundry YAML file. So when you're deploying from the UI, you have seen the form that we fill up. When you're deploying from the CLI, when you're deploying from an IDE, the best way to give the spec would be to use a Service Foundry YAML file. There's an easy way to generate the YAML for this. So you can go back to the form for new deployment, pick a service, pick any workspace, and then fill in the information here. So I'll call it MNIST web app. I'll not fill in the source right now because the source is actually our local IDE. So we'll copy the spec there, but we'll fill it out right here. Path the build context is the root folder. Python version is 3.9. The command to start the application is python app.py. Apart from that, I also have to provide the port. In this case, the port is 8080 because I just configured the port as 8080 in app.py. After that, I also need to provide an environment variable because in the code we are picking up the model version from a model version FQN environment variable. So I'll set that as well. So I'll add an environment variable. This is the key, and the value is the model version FQN. So I'll go to the ML repo. I'll go to next classification. I'll go to our best model and get the model FQN from there. So you just copy it from here like this. Then I come here and enter the value. And instead of submitting, I'll just go to spec and I'll just copy the spec. I'll paste this here in the servicefoundry.yaml file that I just created. In case I can remove the replicas and resources because they are the default values. And I've not changed them, so I can just remove them. The host, I can maybe change it to something like mnist.demo.foundry.com, which sounds nicer. Everything else, I'll leave it at the values that I filled up on the form. Now what I need to do is I need to deploy this. For that, what I can do is first I can log into Service Foundry using Service Foundry login. So I was able to log in. I forgot to mention, in case you already do not have Service Foundry, you can always install it using quick install Service Foundry. I have the package already installed on my virtual environment, but if you do not have it, just run pip install Service Foundry. And after that, you do Service Foundry login. And after that, you want to deploy this. So to deploy this, the only thing you essentially need is Service Foundry.yaml and any sort of files that is required by your application. So in this case, I have this much. And now I can do deploy. And to deploy a command, I need to pass one parameter, which is the workspace FQN. The workspace FQN, I can copy it from here again. I'll go to the workspaces tab. I'll copy the FQN of our MNIST workspace. I'll paste that here and then I'll hit enter. There is some validation errors. The reason for that is because I've not changed the build source here. Since I'm deploying from my local, I'll change the build source type to local. And now I do service foundry deploy again, and it should ideally go through this time. So you can see that deployment has started for the application MNIST web app. We're tailing the logs on the tailing the logs on the CLI as well. but I can just exit from here and I can follow the progress of the application on the UI. So go to deployments, and I should be able to see this new application that has turned up, which is the MNIST web app application that we just deployed. So it'll take a bit to deploy. Meanwhile, you can take a look at the build logs maybe, but otherwise we'll just wait for the deployment to complete. Now it's transitioned from the building stage to the build success stage, and the pods are being provisioned and the deployment is underway. So if I go inside, I can see that a pod is running, and we'll just wait for the deployment to show complete. So deployment is complete as well. You can see that version 1 is succeeded and the pods are running as well, which means if you go to the endpoint, we should be able to see the application. So let's try and go to the endpoint, mnist.demo.truefoundry.com. And sure enough, we have a gradio application running here. We have the title that we configured, which is the MNIST digital classifier. So let's upload a MNIST image. So I think I have an MNIST image on my laptop. I'll pick that and then I hit submit. And as you can see, we have the predictions here. Sure enough, it's number 5. The digit is 5, so it's accurately predicted that. And if I go to the logs, I can see the logs for this application. And if I go to the metrics tab, I can see the metrics as well, the CPU usage, the memory usage, and so on and so forth. In the past few videos, we have seen how we can take the MNIST example. For digit recognition, we deployed a job for training the particular model. We also have parameterized it so we could train multiple jobs with multiple hyperparameters. Then we logged all of these models and their metadata in the ML repo. From there, we were able to pick up one of the models that we thought was the best performing model. And then we use that model to deploy a web application using Gradio, using TrueFoundry deployments. So that concludes the MNIST example of this video series. See you in the next video where we will tie up everything we've learned so far and help you with resources to go forward with your usage of TrueFoundry.